Hey guys, Mr. Hallman here for our third week of distance learning and factoring. In the past 2 weeks, we've talked about two very specific ways of factoring. The first way was to use the greatest common factor and basically reverse distribute a number or variable or both out of however many terms we had, and then write it as the product of that GCF times whatever the leftover factors happen to be. Then we looked at a second way of factoring that didn't necessarily reverse distribute, but instead it was a type of reverse FOIL where we used perfect squares, and we would take a term, a quantity, either two terms or three terms, and we would break it down into either two binomials which had the same terms but different signs, or we would break it into two binomials that were exactly the same. And we called those the difference of squares when we had one plus sign and one minus sign. And we called the others perfect square trinomials where we had both positives or both negatives. So today what we're going to do is we're actually going to move forward into our next method of factoring, because those are not the only two methods of factoring that we have. In fact, most of the factoring that we do does not revolve around special cases like a GCF and perfect squares, but rather it's a little more of a guess and check process, and it involves something that we talked about in the polynomials unit, which is FOIL. So to refresh our memories, here we have an example where we're going to actually have to FOIL. We have m plus 4 times m plus 3. Remember, FOIL stands for the acronym of all the multiplications. We have the first, we have the outside, we have the inside, and we have the last multiplications. So we're going to actually go through here and FOIL. So let's see, our first multiplication was the n times n. That would give us n squared. Then we would do the outside multiplication, which would be the n times the 3. So that would be plus 3n. The inside multiplication would be the 4 times n, which would be plus 4n. And our last multiplication, which would be the last term in each set of parentheses, 3 times 4, which is 12. And then the last thing that we would do is anytime we FOIL, we always want to double check and see, is there anything that can be combined or simplified? In this case, the outside and the inside multiplications are like terms, 3n plus 4n. So we would simplify this to n squared plus 7n plus 12. And that's our basic process of FOIL. We take two binomials and we turn them, in most cases, into a trinomial. So today what we're going to do is we're going to factor, but we're going to do basically the opposite of this process, or rather reverse FOIL. So let's take a look at our first example. Alright, so let's look at our first example of reverse FOIL. The example we have here, x squared plus 10x plus 9, actually doesn't look all that different from something that we would have factored last week. But there are some slight differences when it comes to reverse FOIL as compared to what we saw with the GCF and difference of squares and perfect square trinomials. So to kind of highlight those differences, you can see in the top right hand corner here, there are 4 basic keys to reverse FOIL. We're going to walk through them in this first example and see just how it works. And as I said earlier, reverse FOIL seems like it's more of a guess and check process, but we try and force things to work the way we want them to as much as possible when it comes to reverse FOIL. So let's go through our steps in our process and see what it actually means. So first thing, we know with reverse FOIL, we're going from a trinomial back to a binomial. So we're going to have two terms, or two sets of parentheses here. Oh boy, let's fix this. We're going to have two sets of parentheses. And what we're going to do is we're going to have to figure out how this trinomial should break up into the two sets of two terms. So the first thing we're going to do is we are always going to make sure that we force the first multiplication to work out the way we want it to. Remember, reverse FOIL, that means the first multiplication would be the first term in the first set of parentheses times the first term in the second set of parentheses. That means that multiplication should equal x squared. Well, easiest way to split that up, let's make it x times x. So there's our first step. Second step, in my binomials, I'm going to need plus signs or minus signs. So we're going to force the signs to work out the way we want them to. And the key in this case is going to be the last term sign. So when I look at that last term, the plus means that when I take my last multiplication here, I need to multiply two things to get a positive. Well, to get a positive, I could multiply either a positive times a positive, or I could multiply a negative times a negative. The question is, which of those do I want to choose? To figure that out, I actually want to look at the middle term. So when I look at the middle term here, I see that's a plus sign. That means that both of these things in here need to be pluses, so that when I add them together, I get a positive, but when I multiply them, I also get a positive. So I'm going to go with that choice here. That's our second step. The third step also goes along with the signs, because now we're going to force the last multiplication to work out the way we want it to. Meaning, I want to make sure that, as I said before, the last two terms multiply to give me 9. And this is the big difference from what we saw last week, because, as we know, last week we would have said, oh, 9 is 3 times 3. Here's the problem. 3 times 3 are not the only factors of 9. We could also use 9 and 1. So the question is, which of those sets of factors do I want to use? And you have some options. You could just plug in and then refoil and see if it works out. Or we could use our fourth step. And our fourth step is, how do I check to make sure I'm doing this correctly? I'm going to check the outside plus the inside multiplications. So what that means is, let's say we decide to go with the 3 and the 3. So we plug 3 and 3 in here. Now what I would check is that the outside plus the inside multiplication equals the middle term of my trinomial here. So hopefully when I add the outside and inside multiplications, I get 10x. Well, if I check the outside plus the inside, that means I would have x times 3, which is 3x, plus 3 times x, which is 3x. And that gives me 6x. Unfortunately, I wanted to end up with 10x. So this is not the correct process. But that's okay. If that's not right, that must mean that I have some other factors that I can use instead. So I've eliminated the 3 and the 3. So now let's go back, and instead of using all of those, let's try my other factors of 9 and 1. So just erase all this real quick. Here we go. We're still going to have the binomials, x and x. We have the plus and the plus. But instead of the 3 and the 3, we're going to use 9 and 1. So now when we do our check down here with the outside times the inside, the outside plus the inside, we should hopefully end up with our middle term. So let's see. If I check outside plus inside, my outside multiplication would give me 1x. My inside multiplication would give me 9x, and 1x plus 9x is 10x, which is what I had there. That's good. That means x plus 9 times x plus 1 is my final answer. So as you can see, this is a little bit different from what we did last week. A little guess and check, but the more we do this, hopefully the easier this process is going to become, and the check's going to be a little bit easier for us to do. So let's look at another example. All right, so here's our third example. We have z squared minus 20z plus 51. And again, we're going to go through the process the same way. We're going to set up our binomials here. And remember those 4 keys to reverse FOIL. First key is we want to force the first multiplication. So we're going to force this first multiplication to give us z squared, which means I'm going to split it up into z times z. There's my first step. Second step, I want to force the signs to work out the way I want them to. Again, if I look at the last term, it's a positive. The only way I could get a positive is either a positive times a positive or a negative times a negative. In this case, we go to the middle term, which happens to be negative 20z. So here, I'm going to want to use 2 negatives inside my parentheses. And now the last step, or the last multiplication, we want to force to equal 51. So that means when I take this times this, I should end up with 51. Now the question is, what are my factors of 51? So if we think about it, let's see, definitely 1 times 51. 2 is not. 3 is a factor if I take 3 times 17. And now if you recall back to the GCF method, if I look, 17 can't be factored again. So these are the only factors we have, 1 times 51 or 3 times 17. And the key is I want one of these sets to not just multiply to 51, which I know they will, but they also need to add up to negative 20z. So the question is, which of these, when I add them, will give me negative 20? Well, that would have to be the 3 and the 17. Because if I have negative 3 and negative 17, when I do my check, the outside plus the inside multiplication should equal the middle. So let's see, the outside here would be negative 17z, and the inside would be negative 3z, and that would equal negative 20z, which is indeed the middle term. So that means this is set up correctly. Therefore, my final answer is z minus 3 times z minus 17. Now, some people wonder, does it have to be the minus 3 first? Could I have done z minus 17 times z minus 3? And the answer is yes. I could switch the order of the binomials. If you recall back in the beginning of the year, commutative property tells me I can multiply in any order I want. So if I wanted to switch those, that would be fine. But z minus 3 and z minus 17 have to be the 2 quantities to multiply to get back to the z squared minus 20z plus 51. So there's our second example of reverse FOIL done. Let's take a look at another one. All right, so here in example 4, we have n squared plus 5n minus 6. Let's go through the process. Set up our binomials. Again, our first multiplication here should give us the first term in the trinomial, which means n squared. I'm going to split that into n times n. Next, I want to force the signs to work out the way I want them to. And in this case, I want to end up with a negative when I multiply my last 2 terms. Well, to get a negative, I have to pick one positive and one negative. And it doesn't matter which one comes first, positive or negative, negative or positive. When I multiply them, I'm going to end up with a negative sign. So this is kind of where the guess and check comes in, because I'm not sure which one should go where yet, but I'm just going to plug them in. One plus sign, one minus sign. And now I'm on to forcing my last multiplication to work out the way I want it to. So my last multiplication here, I should end up with 6. So let's think for a second. Factors of 6. We have 1 and 6, or we have 2 and 3. So what we're going to do is we're going to just pick one of those sets and see if it works out. Because I see in the middle that I should have 5. So my first thought is, let's try the 2 and the 3. And since it's a positive, maybe I try the positive 3 and the minus 2 here. What I would want to do to make sure my answer is right is I would check that the outside plus the inside equals the middle term. So in this case, if I check my outside multiplication, outside is negative 2n. Inside is positive 3n. And the middle term should be positive 5n. Well, I run into a problem here because negative 2n plus 3n, that's only 1n. And that does not equal 5n. And this is a problem. And these are some problems that you might face when you reverse FOIL. If you run into this problem where you get the wrong number, what you're going to do is you're going to have to use different factors. As soon as I see that the 2 and the 3 didn't work and it gave me the wrong number, that tells me they are out. So I must have to use the factors of 1 and 6. So now we're going to go back for a second and let's erase these. And let's use 1 and 6, and we'll check our addition here then at the end. But let's plug in the 1 and the 6. And let's just say I put the 1 first, and then I'm going to put the 6. So plus 1 minus 6. So now I'm checking again. I want to make sure that the outside plus the inside gives me the middle term. Well, in this case, my outside term would now be negative 6n. My inside would be plus 1n. And it should equal positive 5n. Problem here is that I get 5, except it's negative 5n. And that is not equal to positive 5n. And this fix is a little bit easier to make, because if I get the wrong signs, then what I want to do is I want to change the sign order. Instead of having the plus in the first set of parentheses and the minus in the second, let's switch them. So we're going to change this from plus 1 to, we're going to make that minus 1. And we're going to make this a positive 6 rather than a negative 6. And what that's going to do is that's going to change this. Instead of being a negative 6n, the outside multiplication is positive 6n. Instead of being a positive 1n for the inside, it's now a negative 1n. So now when I combine my like terms, positive 6 minus 1 gives me positive 5n. That does indeed equal positive 5n, which is a good thing because that means it now works. So there's our final answer, m minus 1 times m plus 6. So you will come across some cases where it doesn't quite work out the way you think it should. You're going to have to plug in and do some checking. You might need to change your factors, or you might need to change the sign order. Let's look at a couple more examples, and then you guys will have some time this week to practice with reverse FOIL. All right, here we go. Example 5. We have j squared plus 5jk minus 14k squared. So one of the big things that you notice probably looking at this problem compared to the last couple is that we have two different variables. We have the j as well as the k. That's fine. We're going to deal with that as we go through. The basic process for reverse FOIL, though, does not change. We set up our binomials. We're going to force the first multiplication. So we're going to force the first to give us the j squared. So that means we're going to use j times j. Next, we force the signs. So I look at the sign of the last term. It's a minus. The only way you get that is a plus times a minus. So we're going to put a positive and a negative sign. The last multiplication is also going to be forced. In this case, we want to force it to give us 14k squared. So that means we're going to take 14k squared and look at our possible factors. Well, we could have 1k and 14k, or we could have 2k and 7k. And this is where, as you go through, if you're writing out your factors, you can save some time on the guessing and checking by just comparing what you have here as far as your factors to what you should end up with in the middle term. The middle term here should be plus 5. So that means I'm looking at which of these two sets of factors actually can combine to give me 5 in some way. And as you're looking at it, you're probably saying 1 and 14, I don't think I can get 5 from those. And you would be right. So we can actually eliminate those choices right away. That means I've now narrowed it down to 2K or 7K. And if I just check 2K versus 7K here, if I go through, my check will show me that I've made a mistake, because when I do the outside plus the inside, I get negative 7JK and positive 2JK. That gives me negative 5JK. We don't want negative 5JK. We want positive 5JK. So this is the problem we ran into last time. We said if we get the wrong sign, but we have the right number, we're actually going to change these signs up. So we're going to change this and this from, instead of a plus and then a minus, to a minus and then a plus. So that way we now have positive 7JK, and then we would have negative 2JK. And that's going to give us a positive 5JK, which is what we want to end up with. So our final answer in this case, J minus 2K times J plus 7K. There's our answer, and we got it. All right, last two examples I want you guys to try on your own. I'll show you the examples. You can pause it and then try it and see how you do. All right, guys, example 6. We have x squared plus 5x minus 36. If you want to pause it and try the process on your own, go ahead. I'm going to walk through the example here in just a second. So what we want to do is set up our binomial times our other binomial. At this point, forcing the first term, you're probably seeing every time we do this, we're splitting up the first term. So x times x. We're going to force our signs to give us a minus, which means we need one positive and one negative. And then we're going to force our last multiplication to give us 36. So 36 in this case has a lot of different factors. We could have 1 and 36. We could have 2 and 18. We could have 3 and 12. We could have 4 and 9. Or we could have 6 and 6. So we actually have 5 different pairs of factors. The key here is we know they're going to be different signs, and when we basically subtract them then, the positive minus the other one, we should end up with positive 5. So the question is, which of these 5 sets can be combined in some way to give us a 5? And you probably said the 4 and the 9 can. If I use a positive 9 and a negative 4, you know that when you do your check, the outside plus the inside becomes negative 4x plus 9x, which is indeed positive 5x. So there's our final answer, x plus 9 times x minus 4. Hopefully you guys got that. If not, let's try one last problem. Alright guys, final example here, number 7, we have x squared minus 11x plus 24. Again, pause the video, try this one on your own, and then when you're ready, restart it and we'll see what we have. Alright, so we set up our binomials. We're going to split up x squared. We're going to force the first multiplication to be x times x. In this case, our last term is a positive. So when I force the signs to give me a positive, I need either positive times positive or a negative times a negative. And I look at the middle sign, which happens to be a negative. So we're going to use 2 minus signs here. And then we're going to force our last multiplication to give us 24. So if I'm looking at my factors of 24, 1 and 24, 2 and 12, 3 and 8, 4, and 6. And I'm looking at which of those basically can add up to 11. So if I look at these different sets, the set that would add up to 11 would be the 3 and the 8. And it doesn't matter if you put the 3 first or the 8 first. When I check, the outside plus the inside, that's going to give me negative 8x and negative 3x, which is negative 11x. It worked out. There is our final answer, x minus 3 times x minus 8. Alright guys, I hope that this video is helpful. We will have our weekly Zoom meeting at the regular time. So this week, probably more than any of the previous weeks, I would definitely encourage you to stop by. We'll go over some other examples together on Wednesday, and I will answer any questions that you have. Otherwise, this week's assignments, IXL, practice with reverse FOIL, as well as a graded assignment on a review of GCF and difference of squares or perfect square trinomials. You'll see that in the folder. Thanks for watching, guys. I hope you're all doing well. Take care and good luck.